Hi everyone, welcome back to my channel. So in this video we'll see how we can solve this short equation. Sine of theta plus 30 is equal to 0.7. The first thing we need to see is that sine is positive, so that means it is found in quadrants where sine is positive, and also we see that the angles of our interest are in between 0 and then 360 degrees. So that's another condition we need to follow. Theta has to be within this range. So we need to revisit our quadrants and recall that if you have a circle and then you have all these quadrants, in the first quadrant all is positive, so all the ratios are positives, tan, sine, cos, and all that, they are positives. And then in second quadrant sine is positive, in the third quadrant tan is positive, and then in the fourth quadrant only cos is a positive. So what is our point of focus on these four quadrants? Our focus is in the first quadrant where sine is positive, and then in the second quadrant where it is positive too. So that means all the angles we need to generate are supposed to be within these two quadrants, and we know this is 180, 270, and this is 360. Also realize that we have this plus 30, and so that means that angle will be subtracted off from the other side, and so which means that we need to generate more higher angles since we in order to cater for the subtraction of that. So let's begin. If you have sine of theta plus 30 degrees, this is equal to 0.7. So that means theta plus 30 degrees is the sine inverse of 0.7. And so let's see what we have from this side. So I'll keep this on this other side. So we have theta plus 30 degrees is equal to the sine inverse of 0.7, which gives us 44.4. So this is giving us 44.4 degrees. We'll keep it to one decimal place. So now we need to think that is an acute angle that falls in the first quadrant. Now we need to generate more other angles, and to do that I'm going to draw another clear circle, and then we see how we are going to extract all these other angles. So our first angle, which I am going to call alpha, is the one which you have just calculated, that is equal to 44. I'll just call it that. So then our next possible angle falls in the second quadrant, again that is alpha. So the target is to move from 0 and generate all other possible angles. So how do we do that? This is 360. So when you move from here, this is already our first angle, which is 45, and you realize that the second angle is also here, and that is going to be in other words 180. Take off this angle to give us this balance, and so we are going to have our other angle as 180 take off 44.4, and that gives us turns out to be 135.6 degrees. Let's see if we move further. If we move further, if we rotate further, we are going to be at 270, 360. So if we move further around here, it will be 360 plus alpha, which alpha is already 44 degrees. But then you observe that when it comes to solving for theta, we are going to be taking off this 30, and so to generate an angle here which is going to be 360 plus 44, which in other words is in 400, taking off 30 is not going to reduce it back to this range. And so what it means that the only possible angles of theta that satisfies this equation and also theta falling in this range are only these two. And so from here we are going to have that theta is equal to we are taking off 30 from here because it will be subtracted off, and so that turns out to be 14.4 degrees, and then also take off 30 from here, which reduces to 105.6 degrees. So you realize that these are the possible angles for theta. If we had generated another angle here, that is 360 plus that, it would not, even if we subtract 30, it would not come back to, it would be still more than 360, which doesn't follow this condition. So that's how we can go about that. Thank you so much. If you like these videos, please leave a comment.